At the outermost fringes of our solar system, beyond the orbit of Neptune and deep within the Kuiper Belt, lies Pluto, a world that challenges our notions of planethood and cosmic scale. Small, icy, and remote, Pluto has fascinated astronomers and dreamers alike since its discovery in 1930. It is a distant world bathed in twilight, where sunlight is a pale memory and temperatures plunge to nearly minus 400 degrees Fahrenheit. Yet despite this forbidding cold and distance, Pluto boasts something truly remarkable: an atmosphere. Not a thick, roaring sea of gases like Earth's, but a delicate, tenuous veil of air so thin it's almost invisible. This atmosphere is a fragile, whisper-thin shroud made mostly of nitrogen, with traces of methane and carbon monoxide, suspended over a surface coated in frozen ices. Its pressure is but a tiny fraction, about 100,000th, of Earth's atmospheric pressure at sea level. To the human senses, this atmosphere would be barely perceptible, a ghostly breath of air more felt by science than by sight or sound. Yet, within this thin veil lies a world of complexity, a dynamic system of processes that breathes life into an otherwise cold and silent world. To grasp the nature of Pluto's atmosphere, we must first understand the relationship between this distant dwarf planet and the Sun, a relationship defined by distance and subtlety. Though Pluto orbits some 4.7 billion miles away from the Sun, the faint solar energy that reaches it is just enough to trigger a remarkable cycle of sublimation. The nitrogen, methane, and carbon monoxide frozen on Pluto's surface quietly shift directly from solid ice into gas, a process that replenishes the atmosphere and sustains it against the vacuum of space. But this is no static atmosphere. Pluto's orbit is highly elliptical, meaning that its distance from the Sun varies greatly over its 248-year-long year. When Pluto is near perihelion, its closest approach to the Sun, the rising temperatures cause the frozen ices to sublimate more vigorously, thickening the atmosphere. As Pluto moves away, this fragile atmosphere gradually collapses, freezing back onto the surface and disappearing almost entirely. This seasonal cycle is a slow, majestic breathing, an exhalation and inhalation stretching over decades and centuries. Such cycles create weather patterns unlike any we know on Earth or elsewhere. Though thin, the atmosphere carries winds that gently sweep across icy plains, shaping the surface and redistributing materials. The haze particles suspended high above the surface, created by complex photochemical reactions triggered by sunlight breaking apart methane molecules, drift slowly, layering Pluto's sky in a soft, otherworldly glow. Our knowledge of these atmospheric wonders leapt forward in July 2015, when the New Horizons spacecraft made its historic flyby. After a journey of nearly 10 years, New Horizons revealed Pluto's atmosphere in stunning detail for the first time. It showed a multi-layered haze reaching hundreds of miles above the surface, an ethereal fog, glowing faintly in the dim sunlight. This haze hinted at complex chemical processes transforming simple gases into intricate hydrocarbons, perhaps even the precursors to organic molecules. New Horizons also discovered that Pluto's atmosphere is escaping, slowly, steadily, into the void of space. Solar ultraviolet radiation breaks down methane molecules, releasing hydrogen and other gases that escape Pluto's weak gravity. The solar wind sweeps these escaping gases away, forming a tenuous, comet-like tail trailing behind Pluto as it journeys through the solar system. This escape of atmosphere is more than just a scientific curiosity. It reveals Pluto as a world in flux, reshaped by time and cosmic forces. Over millions or billions of years, this slow loss of gases alters the surface composition and atmospheric density, a subtle but profound transformation. Pluto's atmosphere teaches us about the resilience of planetary environments, about how even the smallest, coldest worlds can host dynamic, evolving climates. It challenges the notion that atmosphere requires warmth or density to be meaningful. Instead, Pluto shows us that atmosphere is about balance, cycles, and interaction between ice and gas, sun and planet, chemistry and physics. To understand Pluto's atmosphere is to appreciate the delicate interplay between chemistry and environment. Nitrogen dominates because it is the most volatile gas frozen on the surface, sublimating most readily in Pluto's conditions. Methane, though a minor component, plays an outsized role, driving haze formation and participating in complex photochemical reactions that create the subtle colors observed in Pluto's hazy sky. Carbon monoxide, another trace gas, adds to the chemical dance, its presence revealing the diversity of Pluto's atmospheric composition. These molecules cycle between the surface and atmosphere, depositing and evaporating with Pluto's seasons and solar cycles. Each year, or rather, each Pluto year, the atmosphere thickens and thins, reflecting a rhythm dictated by the distant star's light and Pluto's eccentric orbit. This interplay extends even beyond the planet itself. Pluto's atmosphere interacts with its largest moon, Charon, which orbits so closely that the two bodies form a gravitationally bound pair, a binary system. Though Charon lacks a significant atmosphere, studies suggest that some of Pluto's escaping gases may travel toward Charon, perhaps influencing its surface chemistry. The discovery of Pluto's atmosphere, once thought impossible for such a small, cold world, reminds us of the surprises the universe holds, that in the most unlikely places, dynamic processes unfold. That thin does not mean insignificant. That power can emerge from fragility. But beyond the science, Pluto's atmosphere stirs the imagination. It evokes images of a distant twilight world, where the sun is a brilliant star in a sky of endless black, where delicate hazes drift above frozen nitrogen plains, and where the air, though thin, dances in silent rhythms shaped by time and light. It invites us to ponder the nature of worlds far beyond our own, to imagine what it would be like to stand on Pluto's surface, feel the faintest trace of air brush your skin, and gaze upward at the shimmering haze and the stars beyond. To consider how this fragile atmosphere connects Pluto to the sun, to the solar wind, and to the cosmos. In the grand mosaic of the solar system, Pluto and its whisper-thin atmosphere remind us that every world has a story, that the universe is rich in diversity, a place where even the faintest breath of atmosphere is a sign of life and change. And so, as we turn our eyes to the dark edge of our solar system, we remember, Pluto's atmosphere may be thin, but it is powerful. Powerful in its persistence, powerful in its complexity, powerful in its quiet, persistent dance with the sun. It is a testament to the resilience of worlds, the subtlety of nature, and the boundless wonder of the cosmos. A fragile veil of gas that tells a story billions of years in the making, a story of ice and light, chemistry and change, a story that continues to unfold, waiting for us to listen and learn.